Staten Island Express continues. Pine Hollow Auto Diagnostics. 2004 Chrysler Pacifica. Check engine lights on. Something to do with oxygen sensors. Brand new sensors, obviously already installed. Here's the code. Bank 1, sensor 1. O2 sensor heater performance / rationality. Just took a quick peek under the hood. It's a 3.5 liter V6, but there's only one upstream and one downstream sensors, so hopefully this will be more straightforward than some of the cars around here. Let's just pull up the data stream and from a cold start see how these things react. Here's our whole list. Customize that guy. RPM, loop status, DPS percent, and we care about, oh, it even has desired voltage and the downstream voltage. And I guess we have our short-term adaptation, long-term adaptation. That's all we really need to look at here. Alright, so 1 voltage, let's look at that, and the 1 2. So that's interesting. This one starts at 5, this one starts at 3. Was there also a heater? There we go, DC percent heater PIDs. I just want to see if the heater's commanded on. So 1 1 1 2. Let's do it. Look at that, long-term adaptation minus 32. Guys, that O2 sensor is stuck at 5 volts. Look at the downstream, that's coming alive. So obviously if our O2 sensor is pegged rich or pegged high, the adaptation is going to be very negative. It's going to take fuel away. And look, it's trying to heat up that front O2 sensor. Nothing's happening. Open loop. That's all I want to see. Let's get to that connector for the O2 sensor. Check the heater, check the sensor, check wiring integrity. Our basic O2 sensor checks. So the connector for the upstream sensor is right there. I got a couple AES wave adapters to the baby test light on the heater circuit. So whenever this thing runs and the heater says, let's see, that it's on, that test light should light up. So our voltage, bias voltage, is still high. That's so we haven't determined if the wiring integrity is any good yet on the signal circuit. I just want to check the heater right now. See, 100%. And our test light is not lit. Interesting. Huh. That's good to know. Next step, let's check the wiring integrity of the signal circuit. So I moved my test light to the other 2 pins on the connector, and what should happen? If that bias voltage gets to here and goes, the test light will basically ground out the bias voltage. So if our O2 signal drops from 5 to 0, we'll check the wiring integrity of the signal wire and the ground wire basically in one shot. Super easy. Oh look, 2.48. and that's what the upstream one starts out as. Well, that's cool. Very interesting. I'm almost tempted to put a voltmeter on the test light, but how can I have 2 volts across the test light? The test light is pretty low resistance compared to an oxygen sensor, so it should draw it down all the way. But yeah, well, let's experiment a little bit. Very interesting. Check this out. We're at 0 volts on the upstream oxygen sensor, and the only thing I did was ground out one of the pins. This black wire, just connect to ground. If I disconnect that ground, we're up to 2.5. If we connect the ground to the other leg of the test light, let's see what happens. Single-handed. Boom. Okay. It drops to 0. Okay, so basically that sensor ground isn't a direct ground in this design. It goes to the computer. So if there's some continuity through the sensor, you should start at 2.5 volts, just like the downstream's doing. So right now it's looking like a bad O2 sensor. However, we should still check the heater. I want to see the heater turn on. And what else? I mean, the heater might not turn on through the test light because, you know, the resistance is different. So a few different variables here for sure. However, we can at least say our wiring integrity for the signal side is 100% verified. Okay, so 2 test lights hooked up. One is on the signal side to make the computer happy, you know, at 2.5 volts. And the second one is on the heater circuit to see if the heater turns on when the car starts up, when this thing says, you know, 100%. You see it's at 0 right now. Yeah, test light's definitely off. Why would that be? Alright, let's just exit out of here. Clear the codes. Just want to erase the fuel trims. Continue. No codes present. Go back to our data stream. Okay. Long-term adaptation still at -32. Let's start up. Okay, they're both at 100. Test light is not lit. Look, that went to 0 quickly. Still an open loop. So the control, it tried turning on the heater even though the test light did not light, so that's kind of weird. And the O2 voltage is 2.4. Okay, so basically right now we still don't know if the heater on the upstream, if the circuit integrity is good. We haven't verified that. We haven't seen the test light light up on the heater, you know, going across the heater pins. So what do we do from here? I want to see. There's an adaptive fuel reset. Let's try that. Engine running, engine off. Okay. Adaptive fuel, let's reset that. Okay, memory's now reset. Excellent. Back. Data. So now our long term should be 0 or close to it. It's still minus 32. That's crazy. Ah, there he goes. 0 and 0. Test light is not lit. But look, it's trying to turn the heater on for the upstream. It's trying a little bit. We can put a scope on there, see if the control is there for sure. Why the hell not? Let's try it. Oh, and one more thing, check it out. The short-term adaptation, now it's trying to add fuel because apparently 2.5 through my test light is too low. It's trying to drive it up. Very interesting. So for checking the heater circuit for this oxygen sensor, it is very, very important to know, is it power side switched or is it ground side switched? Because that will affect your testing. Is there a constant power, like from an ASD relay or the key on, and then it's ground side switched by the computer? Or is there a constant ground and it's power side switched by the computer? Or the computer gonna have control of both heater wires, especially on newer cars. So jump into our component test information, and just by looking at the pinouts here, we have ground, heater control, and then PCM, ground, and O2 signal. So that right there tells me we have one constant ground, and the heater control is power side switched by the computer. Let's read a little bit. So 2.5 to 3.5 with the sensor connected. 4-wire sensors are heated zirconium. Da, 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 da. Okay, so pulse width modulated voltage is supplied to O2 heater from PCM and a permanent ground. Perfect, perfect. So let's jump out here. So these two wires are the heater control wires. One of them should be a constant ground, one of them should be a pulse power from the computer. Let's find a constant ground first. Test light, battery positive. If it finds a ground, it's going to light up. Is that wire ground? Nope. Is this wire ground? Yep. So we just verified 3 out of 4 wires. We know the signal ground and signal wire, that's good. We verified that. And now we just verified the constant ground for the O2 heater. Now we want to switch our test light to battery ground over here. So whenever it finds a positive, it's going to light up. And this is our positive wire now coming from the PCM. So whenever the PCM decides to turn this thing on, our test light should, in theory, light up. Let's bring it over here so we can see it on the windshield. Oh, come on. We'll be able to see that guy through there. Now, we can just start the vehicle, see if it lights up. I don't like it. I don't like that at all, because computer power side switched heater, that's not there, then could be a bad driver in the PCM. I don't want to make that call. NGC controllers are a pulse width modulated 12 volt output to regulate the O2 heater temperature. Connects test leads, yellow to heater positive, black no good ground. Start engine, monitor voltage. Meter should show 12 volt square wave. That will decrease in duty cycle as heater warms up. If signal is okay, reconnect leads. Da-na-na-na-na. We already knew that. So right now, the only thing we have to do is let's see here. I was wondering if we can just turn on the heater bidirectionally, or just wait until it turns on the data stream. And when it says 100% right here, that test light should be lit bright. Because the test light only draws 250 milliamps. These heaters and the O2 sensors, maybe half an amp or so. So that test light should light up whenever this thing says, 100%. Right there, 100%. No test light. That's our problem. Let's chase that. We gotta go to the computer and see if there's a power feed there. If there is, good news, PCM's good, there's a wiring problem. If not, bad. Going after the PCM. It lives right in front of this left front wheel. What a fantastic location for a computer. Because, electronics, they love moisture and salt and corrosion. I don't know who engineers these cars. I mean, seriously. If I put a computer right here, there's no better place for it, huh? In any case, engine control diagram. There's our upstream oxygen sensor, heater control, and so we verified the ground was good, but our control is missing at the sensor connector. So now we want to go to the C2 pin 18. It's a brown and tan wire, and check for voltage right there. Alright, I got connector C2 all undone. Pin 19 is indeed a brown with a tan. Got it back probed, so I don't want to poke holes in this vicinity. Let's attach a wire to here, test light, see if it lights up or not. Okay, got it plugged back in, back probed, test light going to ground. Let's start it up and let's see what happens to the test light when our data reads 100% duty cycle. Oh man, I thought I'd be done with a few cars by now, but each one of these is taking longer than expected. So mad props to Keith, who can go through 20 to 30 cars a day when they're all this, they can all hang you up. I just have a lot of respect for that. He still manages to get through them. Alright, so O2 heater, start up, 100%. Test light is not lit, that's not a good sign. Not a good sign at all. Last thing we can do is actually back probe the wire just in case, or pierce it just in case my back probe isn't good, but I don't like it. Probably needs a computer. Alright, so this time I got the scope hooked up with no load on the heater. I just want to see a voltage on there whenever we start this thing up. Ooh, look at that. See that? It went to 12 and then went to 0. Now let's start it up. That's actually a good sign. There you go. That's 100%. And the duty cycle should change. Now I want to see what happens if we connect our test light to it at the same time. Let's look at the scan data for a sec. Oh, come on. Dang, he's still plugged in. Oh man, come on. Alright, next check I want to do. On the signal wire, I want to also hook up a test light. And when I ground the test light, I want to see what happens to our signal. Does it get pulled down? What happens? Start up. Test light, boom. Drops to freaking 0. So that right there is easily pulled down to 0 by the test light. There's no current carrying capability on that wire at all. That's nuts. One more thing, if we use the wire that we connected to the O2 sensor connector and put it on the same channel instead of the one I back probed, check it out. Put it on here, boom. We get 12 volts with this stuff. However, again, test light to ground. Should be able to pull that guy down. What's going on? Oh. Right. Here we go. This will pull it to ground. Right there. Interesting. I'm gonna leave that connected. Do the key off again. Okay. Key on. Test light will probably not light, and our voltage probably won't change. Ooh, we got little spikes. We got spikes, so the test light was not pulling it down the ground now. Let's see, start it up. That's pretty cool. So is the PCM capable of providing power, as in voltage, to overcome our test light? Sure looks like it. Very short pulses though. There's the pulse from the PCM. Is that normal? Oh man. So the question still is the computer driver good? Is the test light check valid? We haven't seen the test light light up. However, PCM is doing something. And if we take the test light off, that's what we have. Battery voltage. So you can't light a little test light. And now we don't have any spikes at all. Before we did. Key off. So it could still be PCM strategy if it doesn't like the resistance of the heater and the oxygen sensor. It just freaking won't even turn on a test light. That's a possibility. Maybe it's looking for amperage. Key on. There we go. We have our little pulse. And it's off. Let's see what codes we set. O2 sensor heater circuit high. Cool. Because we disconnect the heater circuit from the oxygen sensor, take away the test light, it'll be high. So the PCM is seeing the heater circuit. It looks like it can provide enough voltage to turn on the heater, and it's just a strategy problem. So You know, some people might say, oh, Ivan, you're overthinking this. Why are you going to all this trouble messing around with an oxygen sensor? Well, it just proves that your traditional test light across the heater, see it light up. Not in this vehicle. Doesn't work. You would say the heater's bad. We went after the computer. The scope actually made us go and say, maybe that's just not a valid test on this vehicle. So that's the kind of stuff that you just can't learn anywhere else. You have to see it on a car. You have to play with it. You have to do your measurements. To fix this, you know, brand new oxygen sensor. What other parts do we throw at it? I'm not sure. I'm curious to try if the connectors fit, maybe plugging in this circuit into the downstream sensor, see if the heater is like happy now. Just kind of play around with it and make heads or tails out of it. Just know the system, figure it out just by doing measurements, looking at diagrams, and taking notes. That's the way to learn. So I'm gonna think about what I want to do here next. We still have to be 100% sure. We can test the resistance of the heater circuit on the oxygen sensor. We should always do that just to see how many ohms it is. But that's that's the process here. So just for reference, the resistance of the upstream sensor heater is 3.9 ohms, which is reasonable. And if you divide V equals IR, right? Ohm's law. So 12 volts equals current times resistance. Resistance is 4 ohms. So 12 volts divided by 4 ohms, we should have about 3 amps at 100% duty cycle on this oxygen sensor. What I did was I connected my high amp test light to the circuit. Still nothing. The pulses changed on the PCM. We're getting a P0032. Man, this car is kind of like starting to take up some time. P0032 O2 sensor heater circuit high. There you go. What I want to do now is plug everything back in. We're still back probed on the PCM. See what the pulses look like with the OEM sensor plugged in. Sensor's plugged back in. Let's just reset all the codes. Clear all the fuel trim stuff. Memory resets. Adaptive fuel. Yes. Okay. Anything else we want to reset in here? Adaptive numerator. Don't know what that is. Back to our data. And our scope is just connected to the heater driver. So again, customize this guy. RPM. Our oxygen sensor stuff. Good enough, right? See the heater DC. O2 sensor voltage. You want to see both of those guys. And we want to monitor our scope. Let's back out a little bit. Alright, so key off, key on. We got some pulses. That was the test. Now let's run it. I don't like this. I don't like it. It's trying, I think. But on the scanner, we see that the duty cycle should be 100%. And it's not. And the sensor's not heating up. This is stuck at 5. Why? Are we throwing any codes? Back to the scope for a second. Get our trigger set up. And I want to zoom in on this guy again. There's your pulse. Why? Why is it doing that? Up to 12, down to 4. This is 0.3 milliseconds. The duty cycle should be, you know, starts at 100% and then it dials it down. It should be at 100%. It's nuts. So we're back to, is the PCM just stupid? It's not heating up his oxygen sensor. No way. What about our loop status? Still an open loop, of course, of course. And our 1.1 is trying to heat up. It's trying to heat up, but this is all we get physically on the control wire. You can see that pulse happens every 100 milliseconds or so 10 times a second, but that's not 100% duty cycle. It's just barely, you know, it's spiking it up and then flatline 0. It's not heating it up. So last check we can do is compare it to a good working, like the downstream sensor. That seems to be heating up just fine. I want to see what a good duty cycle looks like. And by the way, the computer is happy with that oxygen sensor in terms of the heater. No codes present. However, it didn't run long enough to, you know, say the slow response or whatever the initial code was. Okay, that's fine. Let's find the pin and back probe the downstream heater control. So the downstream heater control is on a different connector, C3 pin 9, black and orange wire. Ah, that sucks. I thought it would be in the same connector like next door. So we already ripped apart one connector here. You don't want to do it again? Alright, I did it. I poked a hole in the downstream control wire. We got 2 channels now. Let's fire this thing up. There we go. See, that's what duty cycle should look like. It was at 100, now it's at like 50. Beautiful. Number 1, dead in the freaking water. That's it. It's a PCM problem. I swear. Should we check powers and grounds? If one oxygen heater works, the other one should too. That's it. I'm calling this PCM. And if I get it wrong, then Keith, I'm sorry, man. But I'm done with this car. Thanks for watching. See you guys next time. Bye-bye. Just a little bonus footage. I wanted to put the test light on the good, known good downstream heater control. So everything's plugged in. I'm just piercing that control wire, test light to ground. We fire this thing up. There you go. Test light's lit. So the PCM should be able to control, you know, should be able to light a test light on that heater control for sure. Just because the heater draws more amperage than the test light anyways. So all that stuff about the strategy, yes, it can still apply, but in this case, we're still, you know, you can still use the traditional method. And that method, even though we kind of doubted it, would have still given us the correct answer. The computer can't even light a test light. Wiring's good. It's a driver problem. So that's it. Look, it's if we look at scan data, it should be about 50%. It's kind of flickering a little bit, getting dimmer. No fault codes. That's cool. So look at that, 73% right now on the downstream, and the bulb is getting a little dimmer. It's flickering. We're bouncing between 70 and 80%. duty cycle. If we disconnect the bulb, look at that. Back up to about 30%, 40%. So I think the computer is pretty smart. It wants to keep the oxygen sensor alive, so it heats it just enough to keep it alive. And that test light was drawing a little more amperage, so the computer had to put out a bigger duty cycle to keep both the test light and the oxygen sensor heater happy. So I'm going to reconnect it with 100%. It's going to come back down to whatever it was here, like 80. That's pretty cool. So I think digging deep like this is actually very worthwhile. You just learn more about the system, more than you can learn from all data or reading circuit descriptions or even, anything. You got to play with these things if you want to learn more. So it's not just about, oh, you didn't diagnose in 5 minutes, check the basics, there's no fun in that. You got to learn something. So yeah, that's the whole point of the videos too. Is basically play around with the systems and learn more about them, even though if the diag is straightforward or not, that's not really the point. We figure out the problem, but also learn about the system. So bonus footage, hope you enjoyed that. I'll see you guys next time. Bye-bye.